First, let me give you a little lay of the land here. This is what the code looks like here, the layout. We're going to go through each of these files one by one throughout the video, so don't worry. And here's the make file that I have that's going to drive everything. And really not much magic here, just wrapping a few commands to make our video life easier. First up, I want to talk about dynamic GOMAXPROCS. So I have 32 CPU cores on this machine, as shown here by nproc. And if I go back to Go 124 for a second, and I do look at the code here, you can see that you can use the runtime.GOMAXPROCS function. You can call it with a integer, either to set the number of CPUs the runtime should use, or to retrieve this number of CPUs the runtime can use. And this is pretty nice because you're able to use this to set sort of like kind of concurrency values, right? You can use this as a bounds for your Go routine worker pools or such. And this is a very typical thing. But in Go 124, this doesn't dynamically change when the quotas, maybe in your container, in your Kubernetes pod, or even in your systemd C groups slice or scope, when they change the quotas around you, Go 124 can't pick up those changes. So here I have some code where I create a new GOMAXPROCSWatcher, and I'll show you the code in a second. That watcher watches the GOMAXPROCS value for changes, and it returns a channel to say, hey, every time I have a new value of GOMAXPROCS, I'll return that value over the channel to you. And we'll do that every 1 second. We'll check for a new value. Then I'll grab the CPUs from GOMAXPROCS directly, just so I know how many CPUs I have to start. And then I'll just loop forever and waiting for a value to change, right? The GOMAXPROCS value to change and come back to me on the channel. And then I'll print, hey, I received an update, and I'll keep track of the CPUs that I have updated. Otherwise, I'll just print the number of CPUs I'm working with and simulate some work. So this code's very simple, but it shows a cool pattern where if you wanted to retrieve values or changes to GOMAXPROCS in Go 124, you'd have to use some third-party package to do that because the runtime itself didn't support this. And let me show you what I mean. So if I actually make this real quick, so I'm running this GOMAXPROCS binary that you just saw there. I'm running it in a systemd user slice and its own scope. It's actually running in this GOMAXPROCS scope here, and it's been given no restrictions on CPU quotas. See, it's using all 32 CPU cores on my machine. If I cat the C group like CPU max for this scope, you'll see that it has no limit, right? It's able to use max number of microseconds for every 100,000 microseconds of period. That's what these two numbers are. It's the quota over the period. If I were to like set this though, so if I like set the quota to 100% and look at this file, now we're only able to use 100,000 microseconds out of every 100,000 microseconds, or basically one core. So in this case, you'll see Go 124, nothing's changed. No matter what I do to dynamically adjust these CPU cores, so if I do maybe 700%, no matter what I do to change the CPU quota that my process is running in, the C group that it's running in, the runtime in Go 124 can't see that live. You would need to use some third-party library to see that live, which is kind of a shame, right? Because you want to be able to dynamically adjust Go routine worker pools and so on and so forth. But let me switch to Go 125. So I will switch over here and I will run that again, GOMAXPROCS. And now I'm running the same program built with the Go 125 runtime. And you'll see that it's using the default of, max CPU quota. So all 32 cores on my machine. And if I go back here and I set the CPU quota to 700% again, and I show you that it's at, 700,000 out of 100,000 quota, you'll notice that it updated live. The runtime in Go 125 was able to see that change. And I'll do it again. I'll set this just to, we'll set it to 1200%. And you'll see that it gets updated again. This is amazing because now you can write code that dynamically scales Go routine worker pools or whatever you need to meet your IO bound, your CPU bound workloads or your IO bound workloads, whatever you really need to. Primarily CPU bound, because if you're scaling GOMAXPROCS, you're probably CPU bound on a workload. Either way, amazing, amazing, amazing. I love this feature in Go 125. And I did want to show you the code real quick, just to show you like how this watcher works. It's a simple struct that holds the channel, the done channel for context cancellation and such, the previous read GOMAXPROCS value. We do a constructor to create the initial values. We have an exported watch function that the user can call, which kicks off a Go routine and returns the channel. And then that internal that unexported watch function just creates a ticker. And then every tick, it'll read GOMAXPROCS, say, hey, has this changed? If it hasn't, go back, wait for the next tick. And if it has changed, update what we've seen and send it to the user. And then we have a exported stop function to allow the user to stop. So that way, they can cancel context or just stop directly. Pretty simple library, pretty powerful though. And you can write one of these libraries too for Go 125 and have full control over your dynamic scaling of GOMAXPROCS. Next, let's talk about JSON v2 package. So in order to use the JSON v2 package, you actually have to set a Go experiment value because it's an experimental package in Go 125. So I'll just set that in both of my lovely terminals here just to show you. And let's look at the code here. So I have a couple of JSON v2 usages here, and you can see that I have just a simple API request struct that's meant to simulate like a request body coming into your API. And then all of these JSON sort of encoding, decoding, marshalling, unmarshalling calls down here. And I want to show you that the main API, even with the JSON v2 package, hasn't changed, right? You can just call json.marshal or json.unmarshal just as you used to do in JSON v1's package. That hasn't changed. What has changed though is there's a new JSON text package that kind of holds all of the JSON parsing sort of logic, and the JSON v2 package has sort of the marshalling and unmarshalling logic, which is kind of interesting. So I like this because you can create your new encoder and you can call json.marshal encode here, passing it the encoder and the API request. And you can actually pass it additional options too, but I'll show you that in a second. And what I like about this is it kind of separates the concerns of what is dealing with JSON parsing and what is dealing with actual like encoding and decoding of JSON. And these are really the 4 kind of popular API methods that you're going to call for marshalling and unmarshalling JSON. Should be very familiar to you. This example is not so, extravagant here, and I'll run it for a sec too so you can see the general example. It's very simple. Marshalling, unmarshalling, nothing crazy. What I did want to show though is the tags syntax. So JSON v2 has a couple of new tags that you're maybe not aware of. They have one called the inline tag, and it does kind of what it says on the tin. The inline tag will take the JSON representation of whatever object it's attached to, whatever struct it's attached to, and it'll basically like inline it when it goes to marshal. So effectively, it's going to do this, right? It's going to pull those fields from the person struct up into the API request, which is kind of neat because doing this in the JSON v1 package was kind of difficult. You'd have to do this yourself. And now you can just pass it as an option when you, as a struct field tag when you use the new JSON v2 package. And you can see here I have the new encoder created with a option. So that's another new feature of the JSON v2 is the ability to pass options to the encoders, which is really nice because otherwise you'd have to create the encoder, set the options, then call the encoder. Here you can just pass it right when you call the encode stuff, when you create the encoder. Super, really nice. So what I like about this is you can make JSON v2 and then tag inline. And you'll see here that when I marshaled to JSON, right, when I take that API request and person object and I marshaled it to JSON, it lifted those 2 fields from the person struct into the API request and inlined it. Super nice. So that's a nice field tag available in JSON v2. Then you have another tag called the unknown tag, which I really like. This unknown tag is kind of cool, and for the reasons why I'm going to show you right now. So again, I have that same API request, but this time I'm using a data field here, which is using the unknown tag here, right? The unknown JSON tag. And what the unknown tag does is it says, hey, if I can't marshal this type, or if I can't like unmarshal this type, I'm going to store all of those attributes that I couldn't unmarshal into a Go type in this field. So effectively what's going to happen here is if I pass some sort of request to body, right? So for example, look at this request body on line 27. If I have a request body here called type, or sorry, with a field called type and another field called person, or another attribute called person, what's going to happen is all of this person stuff will be stored in this data map string any. Super nice, because now I get the ability to pass kind of a variety of data to this API endpoint. And whatever I don't know how to marshal or unmarshal at, request time, I can just store it here in this unknown type and then deal with it later. So let me show you that. So I have this handler function down here that knows how to decode an API request, right? So typical, give me JSON. I'm going to make a Go type out of it. And then with that unknown type, right? So I can switch on the type that I've gotten. If I got a person type, I can then read that unknown data field and read the person object out of it, and then try to marshal that into bytes and then unmarshal that into a person object. And I chose to marshal it again and unmarshal it just for ease of use, but you can do anything you want with those unknown fields. Kind of amazing. So here I'm just showing you, like, it's an easy way to kind of have a API like request body that can hold sort of two different structs without having to go a little bit wild on the Go type system. Because doing this previously in JSON v1 meant you had to like deal with this map string any yourself. Now the unmarshaling populates it for you, and you just have to kind of iterate over it and read it. Really nice. And I'll show you what that looks like real quick. So if I do tags unknown, you'll see here that I've passed two request bodies to this. I passed one with a person and I passed one with an animal, and I was able to get those fields unmarshaled into their respective types. Super cool. And finally, I want to show you how to deal with custom marshaling and unmarshaling. So in JSON v1, you had to implement the JSON marshaller and JSON unmarshaller interfaces. Now they have different interfaces in JSON v2's package. They have a marshaller to and an unmarshaller from. And this is kind of a lot of code here, but I'm going to go through it quickly and you can pause and watch it at your own speed. But again, I have that same API request with the person in it, and I can implement unmarshaling. And what's cool about this is I can do it in a few different ways. I'm showing you one of the APIs here, which is unmarshal JSON from, and it takes a decoder. So it takes a decoder that can see the JSON tokens, and you can do whatever you want with them. So in this case, if I want to unmarshal a API request from some JSON bytes, I first want to check, hey, are we in a JSON object? If we're not, we're done. I want to then read the next token, because if we don't have another token, we're also done. Then I want to keep reading tokens until I find the end of a JSON object. And then as I read those tokens, I'm going to pull out the field name. If the field name is a type, then I can read the type because I know that I'm going to populate the type. And if the field name is a person, then I can unmarshal the person structure within. And if there's any errors, bail. Really nice. This is so nice of an API here because it's very similar to people that write parsing tools, right? You're iterating until you reach to a token. You can peek, you can, parse these tokens. Super, super nice API here to implement unmarshaller from. Similarly, with the other side of marshal to, you get another nice interface to implement. And as unmarshaller took a decoder, marshaller is going to take an encoder of how to actually write JSON bytes from your Go object or your Go structure. So here, if we have an API request, we know the very first thing we want to do is we want to write an object token, right? A curly brace. Then we'll write the type. Then we'll write the person object, actually write the person object's value, and then we'll write the closing brace, the closing curly brace. Super nice API for marshaling and unmarshaling. No more dealing with bytes or whatever. You can still deal with bytes. There are API methods for that in the JSON v2 package, but you can also use these newer sort of encoding token sort of APIs, which I really like. And just to show you the code here, I've created a API request and some bytes, and I use the encoder to encode and decode it with my custom encoder. So I'll run that, and that will be custom. And boom, it called my custom encoder and in my custom decoder and was able to marshal and unmarshal JSON. Amazing. I love what I'm seeing here in the JSON v2 package. I need to spend some more time playing with it and seeing like what the options feel like, what the what sort of ergonomics feel like. I don't know how much I sort of like the split of JSON's primary package and the JSON text package, but I haven't spent enough time using it yet. The last thing I want to talk to you about is the new synctest package. So I'll go back to the GOMAXPROCS sort of watcher that I had before, and I'll show you the synctest package. So synctest allows you to test your concurrent code, right? Your Go routines that you're calling and kind of have a hard time testing. You can use the synctest package to test that. So what effectively happens is every time you call synctest.test, you get what's called a bubble, right? That's what they call it in the docs. It's called a bubble. And in this bubble, you can spawn Go routines and you can call synctest_wait. And synctest_wait will advance the time in the bubble when all Go routines are blocked, right? Durably blocked is what they call it. And when I say advance the time, you're probably like, Matt, what do you mean? In this bubble, time is mocked, right? It's essentially faked, right? They start time at a given point in time, and they only advance the timer manually when Go routines are blocked and need to be unblocked. So they control time is what I'm trying to say. So this is really cool for testing your sort of asynchronous concurrent code. So what I really like about this though is how this works, right? You get your bubble, you can spawn Go routines in that bubble, and you can call synctest_wait. And what's going to happen is synctest_wait will only advance the time when Go routines are durably blocked. And the idea is that time will advance to a point where a Go routine won't be durably blocked, so it can proceed. And this wait also will panic and fail the test if all the Go routines are blocked in a deadlock scenario. So it's a really nice way to test your concurrent code using Go routines and see if there's any like sort of deadlocks or issues. Really, really nice. And what I really, really like about it is I can test my GOMAXPROCSWatcher that I showed you earlier without having to make a single code change to it. I have not touched the GOMAXPROCSWatcher code at all, but I can test it using the synctest. And look at this. I create a new watcher, right, with the channel. And since time doesn't matter here, I can operate at the order of nanoseconds, right? I don't have to worry about anything. I can since time stands still and only moves when synctest wants it to move, I can operate on the order of nanoseconds. So I start my watcher, right? And now I call synctest_wait and I say, hey, advance the time, wait until all my Go routines are blocked and advance the time. And that's what it does here. Then I can look and say, hey, is that channel that the watcher was supposed to spin up, is it open, right? Make sure it's still open. Because if it's not open, something happened with the watcher that I started, and that's a problem. That test should fail. Then I'm going to call stop explicitly on the watcher and say, hey, watcher, stop watching for GOMAXPROCS changes, right? Close your channels, close up, stop what you're doing, clean up after yourself. And then I call synctest_wait again, which advances the time to when the Go routines are no longer blocked. And then now at the end, I can confirm, hey, since I stopped my watcher, that channel should actually be closed now. Super, super cool. Like this is kind of amazing because if you were to test this yourself, like with real wall clock time, it'll be kind of a pain, right? Because you'd have some sort of race conditions or whatever to deal with, kind of a pain to test. But here with this new synctest, I control time and I can control this bubble and make sure that all my Go routines have properly exited and I don't have any sort of deadlock here. So I'm going to run that. So I'm going to run make synctest and you'll see that they run in 0 seconds, which is great, right? Basically no time at all. If you were to test this manually with wall clock time, you'd have to put some sleeps in and whatever. Here, almost instant. So let me look at the other tests though, because I had 2 tests in here. So I had the stop and the context. We know that the GOMAXPROCSWatcher that I've created, it can either be stopped manually by the user calling the stop method, or it can be given a context that times out, right? Or that cancels. And that's another signal for the GOMAXPROCSWatcher to stop. So that's what this second test is doing. It's creating a context that's able to be canceled after a certain timeout. And again, since we're in a synctest bubble, we can operate on the order of nanoseconds rather than having to worry about like milliseconds or whatever, right? Because we control time here. So again, create that context that can time out after 5 nanoseconds. Start the watcher with that context passed in. We're going to sleep right now for 1 nanosecond before the context is going to be canceled. So we're going to wait up until that time so that the sync test will advance the time to 1 nanosecond before the context is canceled. And at this point in my test, I can be like, hey, the context should not have canceled yet. Let me confirm that the context has not canceled. Because if it canceled, that means the timeout's not working properly. Also, if the context hasn't canceled, that channel that the GOMAXPROCSWatcher created should still be open. So let's test that. Then we'll advance the time 1 more nanosecond so that the context does cancel. And if the context cancels, we'll confirm that, right? We want to make sure that the context had a deadline exceeded error because that's a successful cancellation. And then finally, since the context canceled, our watcher should have closed its channel. This is kind of a nice test, right? Because now I'm able to test that the context is canceling and closing my channel and stopping my watcher without having to like spin up some wild sort of testing infrastructure to do it. Mind you, I didn't have to make a code change at all to my GOMAXPROCSWatcher. Amazing. And I already showed you the output of the test, but I want to run it one more time to show you that this all works. And if you are looking at me saying, hey, Matt, what happens if this fails? Like how do you make this fail, right? How do you show the test is doing its job? We'll just change this channel, right? Change this condition here and watch this test fail. So I'm going to change that condition to say, hey, make sure the channel isn't closed. And now I'm saying I hit that error condition where it says, hey, the watcher channel is open on a stop the watcher. That's a problem. Amazing. And they run so fast to do this. I'm really excited for this out of everything. This is probably the most excited I am about whatever's coming in Go 125. Just because when you write concurrent code, it's traditionally been a pain to test. And now it doesn't have to be with the new synctest package. And that's all I want to show you. I like to give a recap of what we do in videos just so you can really learn and understand what's going on. So we covered 3 things from the Go 125 release candidate to show you what's going on. We covered the dynamic GOMAXPROCS. So now in Go 125, as the C groups or the Kubernetes resource limits or your Docker quotas, as those change around your Go program, the runtime will dynamically adjust its GOMAXPROCS value, and you can respond to that in tune. We've also covered the JSON v2 package. Has a slightly different API, but also the same APIs you know and love from the Marshall and unmarshal way. I like what I'm seeing here so far. I like the split of a new JSON v2 package and a JSON text package, but there's some areas where I wonder if the split makes sense or not. So I'm going to keep my eye on that and keep playing with it to figure out. And then finally, we looked at synctest because we wrote a synctest test for our GOMAXPROCSWatcher, and we were able to test its concurrent functionality with a controlled bubble that controls time and has capabilities to wait for Go routines. All amazing features, all coming to Go 125, and I will see you in the next one. Thanks for watching.